What would a language model know if it had never seen the modern world? Not filtered or redacted, simply never exposed to anything after 1930. A vintage language model is a standard transformer trained on text from before a chosen historical date. The premise is simple. The execution is not. The data must be abundant, and it must be free of contamination from the future. Talkie was built by Nick Levine, David Duvenaud of the University of Toronto, and Alec Radford, formerly of OpenAI and a lead author on the original GPT papers. It was released in April 2026 under Apache 2, with funding and compute support from Coefficient Giving and Anthropic. The cutoff is December 31st, 1930. The date isn't sentimental. It is the U.S. public domain boundary, which makes large-scale corpus assembly legally tractable. It also sits just before an enormous wave of scientific and political change, before the digital computer, before the Second World War, before almost everything we now take for granted. The corpus is roughly 260 billion tokens of pre-1931 English language text, books, newspapers, periodicals, scientific journals, patents, and case law. Sourced primarily through the Institutional Data Initiative, the Internet Archive, and the Common Pile. English only by design, because the team felt validating the pipeline required deep familiarity with the source documents. The architecture is deliberately conventional. A 40-layer decoder-only transformer, 13 billion parameters, hidden size 5120, multi-head attention with 40 heads, row P positional encoding, SwiGLU activations, RMSNorm prenorm. Context length is 2048. Vocabulary is 65,540, built on Tiktoken BPE. A few stability refinements, QK normalization, per-head learnable gains, embedding skip connections, but no architectural novelty. The vintage character lives entirely in the data. To isolate that variable, the team trained a modern twin. Same architecture and training flops, but on FineWeb instead of historical text. Any behavioral difference between the two models can be attributed, with caveats, to the training distribution alone. The hardest engineering problem is temporal leakage. Old documents carry modern footnotes. Library metadata is messy. Reprints smuggle in editorial introductions. The team built a document-level n-gram-based anachronism classifier and used it to filter the corpus. The filter is imperfect, and the team says so plainly. An earlier 7 billion parameter Talkie clearly knew about Roosevelt's New Deal. The 13B base model retains awareness of World War II, the United Nations, and the post-war division of Germany. The cutoff is aggressively filtered, not hermetically sealed. There is no digital native text from 1930. Everything was transcribed from physical scans. In controlled experiments, conventional OCR delivered only 30% of the learning efficiency of human transcribed text. Regex cleaning recovered roughly 70%. The team is building a vintage-specific OCR system, having found that modern vision language models hallucinated modern facts directly into the corpus. Post-training was rebuilt from scratch. First, supervised fine-tuning on instruction response pairs extracted from period reference works, etiquette manuals, letter-writing guides, encyclopedias. Second, online direct preference optimization with Claude Sonnet 4.6 as judge. Third, another supervised pass on rejection-sampled dialogues with Claude Opus 4.6. The instruction following score rose from 2 to 3.4 out of 5. Modern Claude in the Loop is an acknowledged compromise. The most conceptually clean experiment is coding. Python did not exist in 1930. Programming as we know it did not exist. So if Talkie can write any working Python, it can only have come from in-context learning. On human eval, vintage models trail web-trained models substantially, but performance is non-zero, and it rises with scale. The flagship example, given the encoder for a rotation cipher, the model produced a working decoder. The solution was a single-character edit, addition swapped for subtraction, but it implies a working grasp of inverse functions, transferred from mathematics to a programming language the model has never seen. Forecasting is measured indirectly. The team scored the surprisingness of 5,000 New York Times historical events under the model. Events before 1930 are predictable. Events after 1930 are not. Surprisingness rises sharply through the 1950s and 60s, then plateaus, exactly the signature you'd expect if the cutoff is largely holding. The instruction tune variant can be talked to. It writes letters in period prose. It speculates about a future it cannot see. It doubts there will be a Second World War. It is a strange and quiet kind of artifact. The scientific case for vintage language models rests on 4 uses. Benchmarks uncontaminated by training data. Forecasting research with a real cutoff to backtest against. Studies of whether models can rederive scientific ideas that came after their data. And isolating how much of modern LLM behavior comes from architecture and scale versus from the specific distribution we call the web. The roadmap is explicit. A GPT-3 class vintage model is planned for summer 2026. Corpus headroom estimates suggest GPT-3 5 class is feasible without changing the cutoff. Beyond that, multilingual expansion, a fully bootstrapped post-training pipeline with vintage models judging themselves, and collaboration with historians on era-appropriate personas. All 3 checkpoints, the vintage base, the instruction tune variant, and the modern twin, are released under Apache 2. The inference library is open. The corpus pipeline is documented. This is research infrastructure, not a product. Talkie is, in the end, a measurement instrument. It cuts the entanglement between memorization and generalization that makes frontier models so difficult to study. It gives us a clean variable in a field that has very few of them.